Let's finish up this video. So we just talked about the rotation angle or the angular displacement, saying that instead of talking about a linear distance traveled, we're going to talk about what angle that an object has rotated through. So the next quantity that we talked about with linear terms was speed or velocity. If you remember, we said our speed was the distance traveled over time, the velocity was the displacement over time. We're talking about linear quantities. Now that we're doing the rotational counterpart, we're going to talk about angular quantities. So instead of a distance, we're going to talk about the angle. So we now have the angular velocity, which we use the letter omega for, and it's going to be the rate of change of the angle. So how fast are you rotating, basically, instead of how fast are you moving. So the rate of change of the angle. The unit for the angular velocity will be radians per second. If you remember, the linear velocity was meters per second. So now our angle has units of radians instead of our linear distance that had units of meters. And the sign convention is the same that we just talked about for the rotation angle, that if we're moving counterclockwise, that's a positive angular velocity omega. If we're moving clockwise, that's a negative omega. So hopefully you see the similarities between these quantities and the linear ones. There is a major difference that we're going to be using a lot of Greek letters when we're talking about angular quantities, but don't let that scare you. It's just another symbol to represent a rotational quantity. So let's do a question about this. We have Rashid and Sophia are riding a merry-go-round that is spinning steadily. Sophia is twice as far from the axis as is Rashid. Sophia's angular velocity is blank that of Rashid. So how does it compare? So you look at a picture and you can see that Sophia is twice as far. The axis was in the center here. So you may think, oh, well, this is like the ladybug. Sophia is going twice as fast. But be careful because it says angular velocity. So we just learned the angular velocity is your change in angle per time. How fast are you rotating? No matter where they are, they're rotating the same angular velocity because they're doing the same number of revolutions per second, so they're traveling the same angle per second. So they're going the same angular velocity. If you remember, I had a note in our introductory slide that I'll just go ahead and go back to it. When I introduced this topic here, every point on a rotating object has the same angular motion but does not have the same linear motion. So let's finish up this video with talking about the next quantity, which is acceleration. So instead of talking about linear acceleration, we're going to talk about angular acceleration. Do you remember how we defined our regular linear acceleration? It was the change in velocity per time. How fast were we speeding up or slowing down? How fast was our velocity changing? Well, now the angular acceleration is how fast our angular velocity is changing. So you're playing Russian roulette. This wheel is spinning. When you first get it moving, it's spinning slowly. Then it speeds up a little bit. So that means the angular velocity is changing. So that means there's angular acceleration. And it's going to be defined, the letter alpha for angular acceleration, the change in omega, the change in angular velocity per time. And the units for the angular acceleration is the radian per second squared. So this is very similar to linear acceleration, which was defined as a change in velocity per time, and it had the units of meters per second squared. So you really want to pay attention to the units, because when you're giving an acceleration, the units tell you, well, am I given an angular acceleration or am I given a linear acceleration? The units are there to help you. So to recap this video, we're just starting our discussion of rotational quantities, where we're finding the rotational equivalent for all of the linear quantities that we've talked about in the past.